Hey kids, Teacher Weber here with part 2 of the adding integers video. Now in part 2, we're going to look at what happens when integers have different signs. And we're still using our integer model where shaded circles represent positive 1 and unshaded circles represent negative 1. So let's take a look. Positive 4 combined with negative 3. If I was to model that out, I would do 4 positives, doink, 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 and 3 negatives, doink, doink, doink. And then, this time I have 0 pairs. I have positives and negatives that can cancel. Every time we have a positive and a negative together, they cancel. So there's a 0 pair, there's a 0 pair, and there's a 0 pair. And I'm left with one lonely little shaded in circle, and that shaded in circle is going to be positive 1 or just 1. Okay, let's take a look at another one. Positive 2 combined with negative 1. Well, if I'm going to model this out, 2 positives will be 2 shaded, and 1 negative will be 1 unshaded. Now look at what I have here. I have a 0 pair. I have 1 0 pair that will cause these to cancel, and there's my answer. My answer is a lonely positive 1. If you look at another group, positive 7 combined with positive 5, if I was to model this one out, we're going to go doink, 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 doink for positive 7, and doink, 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 doink for negative 5. Okay, and now I have 0 pairs there. Every time I have a positive and a negative, they cancel. So that guy and that guy, that guy and that guy, that guy and that guy, those two, and these two. And I'm left with 2 shaded circles for positive 2. I want you to see if you notice a pattern there. Every time when I have different signs, I'm actually subtracting, right? 4 take away 3 is 1, 2 take away 1 is 1, 7 take away 5 is 2. And in every case, I had more positives, so the answer was positive, right? I had more positives here, and more positives here. Let's see if that pattern continues now when I do this group of similar ones. So this is negative 4 combined with positive 3. So let's model this out. 4 negatives would be doink, 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 doink. And 3 positives would be doink, doink, doink. And then if I was to model those out, or identify my 0 pairs, I have 3 0 pairs that will cancel and make 0. There's a 0 pair, there's a 0 pair, there's a 0 pair. And now I'm left with a lonely little unshaded circle, which we would call negative 1. Okay, negative 6 combined with positive 4. Well, let's model this out. So here's 6 negatives, doink, 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 doink. Here's 4 positives, doink, 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 doink. Every time I have a positive and a negative, they cancel and make a 0 pair. Doink, 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 doink. And this time I'm left with 2 lonely unshaded ones, which we will call negative 2. And then my last one in this set, negative 7 combined with positive 5. Well, 7 negatives I will model out with 7 white circles, or 7 unshaded in your case. And 5 positives will be 5 shaded. And every time I have a positive and negative, they cancel. So look at how many 0 pairs I have here. I actually have 5 of them. And I'm left with 2 little lonely unshaded, which makes negative 2. Now look at these 3. In the first 3, we were subtracting and getting a positive answer because we had more positives. In the next 3, we were subtracting, but this time we got negative answers because we had more negatives. 4 negatives compared to 3 positives. 6 negatives compared to 4 positives. 7 negatives compared to 5 positives. One more set of 3. Sometimes integer questions, just the way they're written looks weird. Now this one, people would say, is that 2 minus 3? And I would say that's correct. But I think there's a better way. There's a better way to do this, to think of this. And that's the idea that the sign in front of the integer belongs to the integer. So this is positive 2. And so I would think of this as positive 2 combined with negative 3. So now if I was to model this out, I have 2 positives and I have 3 negatives. And then I would look for my 0 pairs. And I see that I have 2 0 pairs. Doink, 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 doink. And my answer is negative 1. Same thing here. Remember, the sign in front of the integer goes with the integer. This is positive 4. There's no sign there, but there is. It's positive. And this negative sign goes with the 7. This is negative 7. Now people say to me, Mr. Weber, isn't that 4 minus 7? And I actually say, yeah, that's the same thing. But I like to think of it as 4 positives and 7 negatives. So if we were to model this out, 4 positives and 7 negatives. 1, 2, 3, 4, 5, 6, 7. And then look for my 0 pairs. And I count 4 of them, right? Here, 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 here. It doesn't really matter which ones I cross it. I could cancel out this one and this one. They make a 0 pair. And this one and this one. And I'm left with 3 negatives. 3 unshaded circles. And then the last one, 9 and negative 12, right? This is a positive 9 because there's no sign. And this is a negative 12. So if I was to model this out, 9 positives, 1, 2, 3, 4, 5, 6, 7, 8, 9. 12 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cancel out your 0 pairs. Doink. Oops, I'll make this a little better. Doink, 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 doink. You gotta be careful you don't doink too fast here. Doink, 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 doink. And I'm left with 3 little lonely unshaded, which is negative 3. So you can see in every case here, we were still subtracting, right? We were taking things away. 3 minus 2 is 1. 7 minus 4 is 3. 12 minus 9 is 3. But in every case, since we had more negatives, the answer was negative. Same thing here. In every case, we were subtracting. But in every case, since we had more negatives, the answer was negative. And right here, in every case, we were subtracting, but in every case, we had more positive, the answer was positive. So the initial question at the beginning, different signs, what's the pattern with different signs? Well, I think we've established a rule. If the signs are different when combining 2 integers, so different signs when combining 2 integers, subtract the numbers and use the sign of the larger number in the answer. So that's the rule we can use for subtracting integers, right? Different sign, pardon me, that's the rule we can use for integers with a different sign. Different sign, you subtract. Okay, and then going way back here, for same sign, if the signs are the same, you add them and use the common sign. So same sign, add. Different sign, subtract. Hopefully that helps you with your integer assignment today. That's all for now. Flexing Teacher Weber, out.